Hello everyone, welcome back to our channel. Today, we're diving into Project 2, building a smart environmental monitoring system using the SFA30 sensor and the W6300-EVB-Pico2. In this project, we'll use the SFA30 sensor to detect humidity, temperature, and formaldehyde levels via UART communication. The collected data will be sent to Adafruit IO for real-time monitoring using MQTT over Ethernet. We've added an automated fan that turns on when temperature exceeds 25 degrees Celsius. Okay, let's get started. First, let's talk about the components needed. These are the components that we need to use in this project. For the key components. First, this is the SFA30 environmental sensor. This sensor supports both UART and I2C communication and can accurately measure humidity, temperature, and formaldehyde concentration. Perfect for indoor air quality monitoring. For the controller choice, we considered both W6300-EVB-Pico2 and W5100-EVB-Pico2. While both are excellent, the W6300-EVB-Pico2 offers more IP protocols, more sockets, larger internal buffer memory, and uses QSPI interface, making it more powerful for our application. The Pico2 create QSPI to communicate with W6300. So the SPI setup is different from W5100-EVB-Pico2. Given the power of board, we'll be using it for this project. Now let's set up the board. First, head over to the WizNet GitHub to download the CircuitPython for the board. Select the right version and download it. Next, press the Bootsel button to enter bootloader mode. Then drag and drop the uncompressed CircuitPython file onto the board. After transferring the file, wait a few seconds for the installation to finish. Once completed, a new screen will appear. Now, add all required libraries to the lib folder. You can download these from the CircuitPython library page. Once the libraries are downloaded, verify that they are correctly placed in the lib folder. Now, let's look at the circuit connections. You can stop and have a look for the circuit diagram. The SFA30 sensor connects to the Pico's UART pins, GPIO0 and GPIO1. We're using a MOSFET to control the fan via PWM on GPIO2. Cut the fan USB cable and connected it through the MOSFET for safe power control. Always double-check your connections before powering on to avoid any short circuits. For the software setup, if you need a refresher on MQTT and Adafruit IO configuration, check out our previous video linked in the description. In Adafruit IO, I've created 3 feeds: humidity, temperature, and formaldehyde to store our sensor data and set up a dashboard to visualize everything. Now let's look at the code. The Ethernet and MQTT setup is similar to our previous projects, but note that the W6300 uses QSPI. The SPI setup is handled automatically by the board detection. For the sensor initialization, the SFA30 needs 10 seconds to warm up. We send a reset command to prepare the sensor. This byte sequence starts and ends with 7E as frame markers, with D3 being the reset command. After waiting 10 seconds, we send a configuration command to set up continuous measurement mode. When we want to read data, we send a measurement request command. The sensor responds with a data frame containing all 3 readings. Our processing function checks that the response starts and ends with the correct frame markers, then extracts the raw values from bytes 3 through 8. We convert these raw values to real measurements by dividing by their scale factors: 5 for formaldehyde in parts per billion, 100 for humidity in percentage, and 200 for temperature in Celsius. In the main loop, we read sensor data every 3 seconds and publish it to Adafruit IO. We also monitor the temperature, and when it exceeds 25 degrees, we trigger GPIO2 to turn on the fan via PWM. The fan automatically turns off when the temperature drops back below the threshold. Let's see it in action. The board is connected to Ethernet and initializing MQTT connection. The sensor is warming up. Remember, it needs those 10 seconds before accurate readings. Perfect. The data is now streaming to our Adafruit dashboard in real time. You can see the temperature, humidity, and formaldehyde levels updating every 3 seconds. Now, watch what happens when I increase the temperature. And there. As soon as it crosses 25 degrees Celsius, the fan automatically turns on. And when it cools back down below 25, the fan turns off. The system is working perfectly. And that's our environmental monitoring system. We've successfully created a smart device that monitors air quality and automatically controls ventilation. If you enjoyed this project, please give it a thumbs up and subscribe for more IoT tutorials. All the code and circuit diagrams are available in the description below. Thank you for watching, and we'll see you in the next video. Bye-bye.